Okay, sometimes what they'll do, they'll give you a binomial distribution and they won't tell you a number of trials. You've got to work out how many trials it takes for something to happen, in this case, for the probability of at least one success being greater than 0.9. So they'll give you the probability of one success, and you've got to work out something to do with this for n. So you've got to solve for n given this bit of information. So what you've got to do, you've got to look at how we can arrange this. Basically, this is telling us we can have the probability that we have probability of 1, probability of 2, probability of 3, all the way up to the probability of n. That is a lot of possible calculations. We don't know how far we have to go. And what we're doing is we're adding them up. And in doing so, we're going to see that we want them to be greater than 0.9. So we've got to try and work out how many of these we've got to do. Easier said than done. What we need to do, we need to set up our equation. So we know we've got NCX. This is what we looked at earlier. P of x, 1 minus P, n minus x. So this equates to the binom PDF. That's a minus. So what we do is we use our information to solve for this. Now, if we're dealing with this, so we're saying if x is equal to or greater than 1, we want our probability to be greater than 0.9. If that's the case, if we're dealing with x being greater than or equal to 1, that means that is the same as everything else apart from the probability that x equals 0. So now it makes it a hell of a lot more straightforward. If we're looking at 1, it would have to be substituting 1. Then 2, we have to substitute 2. 3, we'd have to substitute 3. 4, we'd have to substitute 4. And then we'd be playing around with it and adding all these things up, but it'd get quite tedious. So what we do, we can use this formula and we perform a substitution. Now that we've got that, we can just do some substitutes. So we're solving for n, so we don't know. N, C, arrange 0 ways. Probability of success is 0.7 to the power of 0. 1 minus 0.7 to the power of n minus 0. So now we've got anything C0 is 1 times anything to the power of 0 is also 1. And now 1 minus 0.7 is 0.3 to the power of n, and that has got to be greater than 0.9. Still to be greater than 0.9. So we've got 0.3 n to the power of 0.9. And remember, use words 1 minus that. So it's 1 minus, 1 minus, and 1 minus. And what we do is we solve that on CAS and we find that n equals 1.91. So n has got to be greater than 1.91. Now, if that's the case, we need a whole number which is greater than that. So 1.91. The next obvious choice is n equals 2. If we weren't sure and we were thinking maybe n equals 1, sorry, n has to be greater than 1, that won't work because we want, because that'll make sure the probability is well over 0.9, whereas we want to find out where it's just over. So that is the better answer because it is closer to 1.91.